Okay, this is 5.2 day 1. We have the assignment where we're skipping over number 10. Don't forget to skip number 10. The formula sheet that I gave you covers section 5.1 and 5.2. This particular pack covers the sum and difference formulas. So sum and difference formulas in the bottom right hand corner of that main formula sheet right here. We're going to start with these here: sine and cosine, sum and difference formulas. On this page, it says we know that cosine of 30 degrees is square root of 3 over 2. Then obtain the exact value of cosine of 30 degrees, knowing that cosine of 90 minus 60 is the same as cosine of 30. These two are the same thing because 90 minus 60 is 30. Okay, so what we're talking about here is using a cosine difference formula. So we're talking about this one. We have the cosine of something minus something. Okay, that would be here, 90 minus 60. So I'm going to call that x and this y. So that we're finding the cosine of 90 minus 60. Okay, so you see that's the formula right here, cosine of x minus y. So I'm going to write out this formula right now. So the cosine of x minus y equals cosine of x times cosine of y plus sine of x times sine of y. Okay, so if this is our x is 90 and our y is 60, then I can rewrite this as, okay, so the cosine of 90 minus 60 degrees would equal the cosine of 90 degrees times the cosine of 60 degrees plus the sine of 90 degrees times the sine of 60 degrees. Alright, now last try we figured out how to find sines and cosines of 90 degrees. It would be 90 degrees is right up here, and on a unit circle we can't draw a triangle to there. We have to essentially just say, well, if this is a unit circle, the radius is 1, and the point right here will then be a 0 value for x, and y would be 1. So we have an x and a y. So cosine is always the same as your x value, so the cosine of 90 degrees is 0. And sine is the same as your y value on a unit circle, so the y value is 1. And then 60 degrees is in the first quadrant. So if we draw a little quick sketch in the first quadrant and we rotate up 60 degrees, and we draw our little triangle like so, the longer side is going to be the square root of 3 over 2, the shorter side is going to be 1/2, and obviously the hypotenuse is 1. So if we want to find the cosine of 60 degrees, it's going to be the horizontal side, which is x, so that's going to be 1/2. And your sine of 60 degrees would be your vertical side, which is square root of 3 over 2. Now obviously 0 times anything is 0, so 0 times 1/2 is 0. 1 times square root of 3 over 2 is square root of 3 over 2. So our final answer is square root of 3 over 2. So that's how we use this formula to find, verify basically, the fact that cosine of 30 degrees is the square root of 3 over 2. Now sometimes we can use the formulas backwards. So in a couple more pages, we have this one. It says find the exact value of all this. Now this looks like the right-hand side of the formula over here. So if I fold these over, you can see the right-hand side of these formulas looks a lot like that. Now, so we have 4 of these. Which one is it here? Well, it's got a plus sign in between, so it's either the first one or the last one. The first one has sine and cosine, cosine, sine. No, the last one's got cosine, cosine, sine, sine. So yes, it must be an interpretation of this last formula down here. So it must be equal to cosine of x minus y. So if x is 70, you can see the x's come first, and the y is 40, y's come second here in each term, then that must be the cosine of 70 minus 40. So if I write that out one more time, the formula that I identified as the one matching in structure with what I've been given, looks like that. So that must mean if on the right hand side we have this, which is cosine of 70, cosine of 40, plus sine of 70, sine of 40, that must mean over here this is cosine of 7 degrees minus 40 degrees, which is the cosine of 30 degrees. So if we want to find the exact value of the cosine of 30 degrees, which is now what we know we're trying to find, we then draw in the first quadrant a quick little triangle where the interior angle here, angle of reference is 30. Opposite from 30 degrees is always 1/2. Adjacent on a 30, 60, 90 would be square root of 3 over 2. So the cosine is going to be your horizontal side, which is going to be this one, which is the square root of 3 over 2. Now, this one's kind of tricky. This one involves taking the sine of 5 pi over 12 and rewriting that as the sine of pi over 6 plus pi over 4. See how I just took this and replaced it with that up there? Okay. So basically, how do I do that when I'm trying to find the sine of two things added together? Well, the sine of two things added together would be like saying I want to add x plus y in the argument, so this I'm basically taking the sine of x and adding y in there, and that's a formula. The sine of x plus y is this: sine of x cosine y, cosine x sine y added together. So if I write down the formula that matches what I'm trying to do here, okay, and I know that x is pi over 6 and y is pi over 4, I can be more specific in exactly what I'm trying to do. Okay, now if you want to draw these triangles out, you can certainly do that. If you have the square root of pi over 4, that's 45 degrees. So in the first quadrant, if this is a 45-degree angle, which is again the same as pi over 4, you get the square root of 2 over 2 on both sides. So both the sine and the cosine, be it the x or the y side, would be the square root of 2 over 2. Here and here, both positive. And then pi over 6 is 30 degrees. And again in the first quadrant you would get 1/2 here, square root of 3 over 2 here, and 1. So the sine would be your vertical side, 1/2. The cosine would be your horizontal side, square root of 3 over 2. And then the rest of this is all just trying to combine things, multiplying it all together. So I've got 1 times the square root of 2, 2 times 2 is 4. Square root of 3 times the square root of 2 is the square root of 6, 2 times 2 is 4, and then if I add it all up together, I get the square root of 2 plus the square root of 6 all over 4 as my final answer there.